Right, this is a great question to think about projectiles in theory and how it works. So if we've got a projectile, what we're thinking about is we've got this curve. So we've got almost like a quadratic equation. And we have our initial our initial velocity, which will be at an angle. So we've got our initial velocity here. This is going to be theta. This is going to be u. And we're going to split that up. So we're going to think about it horizontally and vertically. So if you remember all that stuff that you've done, where you've got to have a look at opposite is sine, adjacent is cos. So we've got u sine theta, u cos theta. Okay, so that's all the information we're given. And we're going to think about this in terms of x and y. Sometimes much easier to think of mechanics in terms of pure maths. Okay, so we've got our Suvat equations. So our Suvat equations are exactly the same as what they are, but we're just going to think about them in horizontal world and in vertical world. So we're going to have SUVAT. We're going to split that horizontally and vertically. Horizontally, it's an x at any point. Vertically, we're thinking y. Our u is going to be u cos theta, u sine theta, and you can literally fill this out whenever you see a projectile question, unless it's in vector form, at which point you'll be given numbers for each of these. So actually vectors and projectiles is easier, right? The other thing we know is horizontally, the a will always be 0. Vertically, it's minus g. The t at any given point is the same. Because a is 0, and we know that v equals u plus at, horizontally, our v is just u cos theta, and y is going to be u sine theta, and then at, which is minus gt. So now what we're going to do is find an expression for x and an expression for y. This is, the dreaded parametrics. They come up as parametrics, which we're then going to put together. So we're going to look at s equals ut plus a half at squared. So let's think of everything horizontally. We're going to have x equals u cos theta t. Now obviously a is 0, so the second half of that disappears. Vertically, we're going to get y equals u sine theta t minus a half gt squared. Okay, now if you have a look at this expression compared to the expression above, there's no t, so we want to rearrange this for t. So we take that first one and we say, well, t equals x divided by u cos theta. And we sub into 2. So we get y equals u sine theta times by x over u cos theta. So what I've done is I'm substituting. So essentially I'm taking all of this and putting it here and here, right? So that blue bit is the same as this bit. And then we're going to have minus a half times g times t squared. So x squared over u squared cos squared theta. Now, if you have a look, there's a few things that are going to cancel out. So we can see that our u's are going to cancel here. And also we'll have sine over cos, so that's going to become tan. And we've got 1 over cos squared, which is going to become sec squared. So we're going to end up with x tan theta minus gx squared on the top, so 1 times g times x squared. And then we've got 2u squared on the bottom, and all of that is multiplied by sec squared theta. Now, hopefully, if you then compare it to what's up there, everything's the same, except for over here, we've got sec squared theta, and here we've got 1 plus tan squared theta. Now, you know from your identities that sec squared theta is the same as 1 plus tan squared theta. So we can simply, from that line there, you will just essentially write the answer out. So you'll just, then your next line will just be x tan theta, I've written tan theta, they've used alpha. So there should really be an alpha there. So tan alpha minus gx squared over 2u squared, 1 plus tan squared alpha. Okay, so in an exam, you could go back and change it, but I don't think they'll knock you the marks. Okay, so now we're going to use that, and we're literally just going to substitute our values in. So if I now take my diagram here, actually let's go back and grab our formula. So we're using the formula in the same form. So we want this formula, which we've just used. So if we put that over here, oops, maybe not. I will just rewrite it, it's probably easier. So we're going to have y equals x tan alpha minus gx squared over 2u squared, 1 plus tan squared alpha. Right, and this should be 10. I think it wasn't changed when we did the question. All right, so we're going to substitute in the values. We can use our y as 3.5, our x as 10, and we're trying to find alpha. So minus g, 10 squared, it tells us u is 20, 1 plus tan squared alpha. So I'm then going to times everything by 2 times 20 squared. So just so we get rid of that as a denominator, so if I do 2 times 20 squared, I get 800, times 3.5 is going to give me, so I'm doing it all in one step. If you need to do more steps, not a problem, 2,800. And then if I do that 800 times 10, I'm always going to get 8,000 tan alpha minus 10 squared g. So 10 squared is 100 times 9.8 is going to give you 980. 1 plus tan squared alpha. So if we open that up, we've got 2800, 8,000 tan alpha minus 980 tan squared alpha. And now when I should be using theta, I've used alpha everywhere. So like I said, I don't think it'll matter too much in the exam, but you're going to do this a bit more carefully and slowly than I am. Okay, so let's rearrange that. We've got 980 tan squared theta minus 8,000 tan theta, and then we've got 2,800 plus 980, so plus 3780 equals 0. Oh, my voice has gone all croaky. Right, so we're going to now go to equation function. Your polynomial, don't bother simplifying it. I know you can get rid of the zeros even, but the more you mess with it, the more likely you'll make the more likely I normally make a mental arithmetic error, do something silly, and then it changes the answer. So tan theta can be 0.5035. So you've just used your polynomial, your quadratic, you're finding the solutions for tan. Now remember, tan is the one that can be above 1. And then you inverse tan both of these. So you're going to get shift tan 0.5035. Make sure you're in degrees. Let's say we'll do it to 1 decimal place. So 26.7. And if I do shift tan of the other one, you're going to get 82.6. So that tells you your theta has to be bigger than 26.7, but less than 82.6. So that's your range of values for when it's going to go over the pole.